Recording has started. All right, guys, welcome. This is May 5th, Cinco de Mayo. Anybody in chat know what Cinco de Mayo celebrates?
I won't answer this because that'd kind of be cheating.
Emily says no idea. Food. Naya says food. I guess celebration includes food, but nobody actually knows what Cinco de Mayo is.
You want me to tell them?
Dianica, you don't know either. All right. Okay, Antonio. Tell me what it is.
So most people's misunderstanding of this is that it's Mexican Independence Day. That's actually in September.
September 16th, I think.
Correct.
Right. Yep. Okay.
Today is when the Mexican army beat the French in the Battle of Puebla.
Yes. In 1867.
Two.
Two?
Yep.
Okay. Well, I got a video for you guys. Before we start math, I have a historical video, and it's only like 30 seconds long, so that's good. All right, so yeah, you guys saw the important stuff in the video. Yeah, that's Cinco de Mayo. More you know, right? Do they? The U.S. celebrates it more. Just I think Americans try to find every reason to party.
Yeah, basically in Mexico, it's not even a big deal. Like literally, no one does anything for it.
Oh, really? Well, there you go. All right, so back to math. All right, so this is from Unit 4, Law of Sines. All right, so consider triangle ABC where side B is 12, side C is 6, and the measure of angle B is 81 degrees. What are the measures of the missing angles and missing sides? So for this one, you get to solve for, well, it looks like everything. So let's do this. It's like a multi-part problem. I'm going to give you 3 minutes, and I want you all to find let's do the angles first. So find the missing angles first. Yeah.
This is not a right triangle, correct?
This is not a right triangle. No. Well, I guess it could be, but highly doubtful. So there's different ways to approach this problem in terms of how you find the sides and the angles. So let's see how we can get on this problem in 3 minutes. Yeah, I don't know about Friday. My calendar says I don't have anything planned. So as far as I know, we have class on Friday. We'll see. Tomorrow I'll let you know. How about that? Did you draw a picture, Antonio? So remember, when you have a triangle, in this case ABC, the capital letters represent the angles, the lowercase levels represent the side opposite of the angle. That should help. Right. Anybody have anything figured out yet for this problem? Anybody have any-
I do, but I think I'm way off. I try to do your trick. I don't think I can in this case. Is small a or side a like 1.9? That doesn't sound right at all.
No, it is not.
Okay, yeah, your trick doesn't work here then. I did something wrong. 1 minute, please.
So I think angle C might be.
Quick question.
Yeah.
Is small side a 8.4? If it's not, then I'm completely doing everything wrong.
Nope.
I don't know what I'm doing right now then. Should I show you the work I'm doing? See if I can get
So
it right.
I would say solving for angle C is the easiest out of all of them. So I would do that first. Julia Danica,
What
tabbed
that
out,
we have
working hard, I hope.
or 0.5 for the fraction at
0.5.
least.
Nope. Oh, wait. That's part of it.
Your cat just randomly said hi to us.
You saw that, huh? Yeah. That's my new cat. I rescued her from the Humane Society. Well, I didn't rescue her. She was given to me without my consent.
30 is the angle. See?
You said 30?
Yeah.
All right, so make sure you round to 1 decimal place, it says. Do I have that written down? What are the... Oh, I didn't say that. So, yeah, you could say 30, but give me 1 decimal place.
If I'm honest, I didn't get this whole place because it's. I don't know how you got this place with that.
Well, how'd you get 30?
Okay, so it's 6 over 12 because opposite over hypotenuse. Half, so I did 0.5, then I arc signed it.
Whoa. So what you're talking about only applies to right triangles. This is not a right triangle. So that's why you have to use the law of sines or the law of cosines, which is a totally different approach than what you're doing.
I'm gonna act like I know what you're saying. I'm gonna go into the distance.
So you should have your formula sheet in front of you that has everything that I typed up, and one of the little sections says law of sines, law of cosines. That's what you want. I think that's on there. I don't remember if I put that on that sheet.
It is.
It is, okay.
If somebody else wants to do this for me, you guys can go ahead and be my guest.
All of you logged in, but aren't actually doing anything except Antonio.
And I'm failing, but I'm trying.
I know. It's okay. Hmm.
Can
All
I
right,
ask if my setup's okay? Okay, never mind. Yeah, that I did it right. Okay.
So, reminder, everyone watching this, these can be flip-flopped. You can have the sides on top and the angles on the bottom. But because we are solving for the angle, I want to keep it on top. So it's the sine of angle C over the opposite side, which is 6, is equal to, and then you want to choose an angle on a side that we know. And we know that angle B is 81 and side B is 12. So we do sine of 81 divided by the opposite side, which is 12. So this is your first setup. And then from here, it's pretty easy to solve. You multiply both sides by 6. You can reduce that 6 over 12 to be 1 over 2 if you wanted to. I don't remember if I did. I did not, but I think that would be probably good to do. Just less to type in, right? So that 6 becomes a 1, the 12 becomes a 2. You don't have to. You can just basically just arc sine both sides and just type it in as you see it.
$29.6. Is that right?
Yeah, sounds right. Yep. And for this one, you want to be in degree mode. So for this test especially, you're probably going back and forth between radian and degree. So make sure that you are in the correct mode before even typing anything in. So 29.6 degrees. All right. So next, we know angle C. We know angle B. How do I find angle A?
Add them together, minus 180.
There you go. So you do 180 minus 81 minus your 29.6. And that's how you would find that third angle. All right. So on your final, I don't believe you have to find everything like I'm making you find, but you do one or the other. I forget, but it's good just to do it all. All right. Next, we have to find the missing side, little a here. We know all of the angles. I'm going to use, well, the 81 degrees and the 12 for sure. And then I'm going to use probably these two would make the most sense to me.
You have to use those A's to find side A.
Yep. And so what I did is to avoid using rounded work, because I always tell you guys, rounded work is usually bad. You want to try to avoid it. So what I did to try to get around that, we know that this angle A is 180 minus 81 minus angle C. And angle C, I just wrote out to as many places I could. And I also stored this value in my calculator. But writing it out that many places is probably fine. I wouldn't use the rounded value. I would use as long as you can if you can't store it in your calculator like I did. But then we just, well, do the math, multiply both sides by that denominator. That's that sine of all that stuff. And then you would type in 12 sine of that stuff all over sine of 81 and hit enter, and What do all of you get? So I want all of you that are here to type this in to see if we can get the right answer.
Is that 11.37?
Oh,
I hate my life.
using your iPhone again.
Yes, I believe by now, after a whole year of school, it has at least earned some kind of respect on some level.
Anybody else typing this in, I hope? Oh, yeah, you need to be in degree mode. And don't forget your parentheses and the formatting. You mistyped it. You mistyped it. So I can promise you this. If you didn't get the answer I got, it's because you didn't type it right. Anybody else want to take a guess? All right. No. Okay. Oh, Diana's typing it in. I'll wait for her. Emily got 11. 11.3732. That's not what I
I'm with
got.
Emily. I think you got it wrong. Me and Emily are both continuing.
I may have gotten it wrong. I'll wait for Diana because I don't want to retype it. Oh, Diana got 11. So maybe I mistyped it. Let me turn on my light, get my glasses. Type stuff.
My Apple calculator beat you this time.
All right, let me. Oh, so maybe I mistyped it. Let's take a look. Okay. Okay. All right, Emily, you win.
Apple calculator for president.
11.3732. So 11 point. So I'll just say 11.4. 11.4 is side A. All right. All right. You win. I fixed my mine. All right. All right. Next problem here. All right. A pizza has equally sized slices. The diameter of the pizza is 14 inches, and the area of a slice is 49 pi over 16 square inches. How many slices of pizza does the pie have? Got this one together. All right, so we need one or both of these formulas, which I put on this page for you, talking about the arc length and also sector area. So you need this to approach this problem here. And then on the side here, we need to write down what the radius is, find out what the area is, or write down the area that's given maybe, and the angle. All right, so what is the radius of this pizza? 7 what? 7 inches? Okay. Agree with you. 7 inches. Okay. And then what is the given area? 49 pi over 16. Okay. Remember that given area is for one slice. And what is, well, so the angle, do we know the angle of that slice? Yeah, no, sir. But think about cutting a pizza. The angle is determined by how many slices you have. So if you don't cut the pizza, what is the angle in radians? If you don't cut a pizza, what's the radians? 2 pi. Agreed. All right. Let's say you cut the pizza in half. So now we have two giant pizzas, right? What is the angle of a slice? You just cut it once in half. Pi, yeah. So you can think of it, if you cut it in half, you have two slices. So you take 2 pi and you divide it by the number of slices. That's what I'm trying to get at here. So the angle is of one slice of pizza is 2 pi divided by the number of slices we have. And that's what we're trying to solve for here. We're trying to solve for, well, the number of slices, right? How many slices of pizza does the pie have? So that's why I have this set up this way. Now, the way I'm approaching this problem, this is not the only way. I think this is maybe, in my opinion, probably the easiest way, though. Not the only way. In order for you to derive this piece right here, you have to understand that the angle per slice is determined by the number of slices we have. Good? All right. Next. Well, we're just going to resolve for x by, switching theta and x, doing that little trick I taught y'all. Oh, sorry, we don't do that yet. So x is number of slices. I talked about that already. All right, next we're going to determine the area. Well, sort of. We're going to use the area formula. Now, in this formula, we are going to plug in what A equals. We're going to plug in what R equals. And we are going to plug in what theta equals. We're going to plug everything that we know. And once you plug everything in, what do you think we do next? All right, everyone solve for x. I'm going to give all of you 2.5 minutes. Everyone solve for x. Another 58 seconds left. All right. How many slices we got? 16 slices. All right. Looks like 2 of you are working this out. 3 of you. All right. All right. I think everyone's now following suit of just putting 16. Is this true, Julia? Okay. Okay. That's what you got. Okay. I'll believe you. It is 16. I also agree. So I think that's probably the easiest way to approach this problem. Not the only way. Everyone good on this one? A Ferris wheel has a diameter of 56 feet. It completes 15 revolutions in 17 minutes. What is the linear velocity of the Ferris wheel in inches per second? So that's important. Inches per second. Round answer to the nearest tenth. Okay. Okay, so just like last problem, we need some information. That's what we're going to use, this stuff here. So start off by writing down what we know. So what's the radius of this Ferris wheel? 28 what? 28 what, Antonio? 8. So on your final, don't forget to put the units when you write down your values. 28 feet. Now, in this problem, they want the answer in inches per second. So what does that tell us that we probably need to do? Convert, yep. So how do I convert 28 feet into inches? Multiply by 12, yep. 12 inches in 1 foot. This is that whole stoichiometry stuff, right? 12 inches in 1 foot. So yes, 336 inches. All right. Do we know the angle yet? We kind of do, yeah. So this one is a little different than the last one. The angle is central angle measure in radians. So looking at this word problem, do we know the angle, the total measure of the angle traveled? So it's 15 revolutions. That's important to determine the actual angle here. "15 revolutions." Not yet. Nope. Now, if I said it made 1 revolution, what would the angle be? Radians. I want it in radians, please. In radians. 2 pi. Okay, so 1 revolution is 2 pi. What's 2 revolutions in radians? 4 pi. All right. So then what's 15 revolutions? 30 pi. Yes. 15 revolutions times 2 pi, because that's 1 revolution. So we have 30 pi is the angle. So this is the angle traveled in this case. What is the time it takes? "17 minutes." I meant to cover that up. 17 minutes. Oh, well. Which you can probably guess because I have a blue box here. We're not done with 17 minutes. What does it need to be in what units? It needs to be in seconds, yes. So how do I convert minutes into seconds? Multiply by 60. Yeah, absolutely. Because there is 60 seconds in 1 minute. Oh, and just to show it's the stuff crossing off here, so feet and feet cancel out, minutes and minutes cancel out. If I'm showing my work, that is. And again, for this problem, we know we need inches because they want the answer in inches per second. We know we want seconds, well, because it says, well, per second. So the feet must be converted into inches. The minutes must be converted into seconds. Now, we could have saved the conversion to the very, very end, but I think it's usually easier to convert it now if we can. All right, so now that I have the radius, I have the angle, I have the time, we're going to use one of these equations. Which one are we going to use? The first one, the second one, or the third one? It was right, the second one. R theta divided by t. Everyone plug this stuff in and solve for v. And when you have an answer, go ahead and just write it in chat.
We don't want exact track. We want it in inches per second.
We want it in inches per second, and it says round to the nearest tenth. Yep.
Gotcha. $31 flat. Because it's 0.04, but that won't actually round up to anything.
Sounds good to me. Yep, 31. Oops, I put foot per seconds. I meant inches. Oh, silly me. Thank you, Antonio.
You're welcome.
That N looks like my 4.
It's capitalized N.
Ooh, this is a fun one. All right, so you need to use your trig identities to put, well, this in order. These really aren't that hard, in my opinion. Now, if you try to look at the answers to kind of, I don't know. I think looking at the answers now to try to figure out where it goes is harder than actually doing the math. But it can help. So let's do this. I'm gonna label these A through whatever. A, B, C, D, E, F, and G. All right, I'm gonna give all of you 2.5 minutes again to try to put this, well, fill in the blanks, put it in order. This is not really even a proof. I guess kind of is. It does say proof, so a hard proof. So remember, usually you want to convert your cosecant, secant, and cotangent into one of the fundamental trig functions. It's usually what you would want to do first. You really want everything in terms of sine and cosine. That's what we talked about on this unit. Get everything in terms of sine and cosine. All right, look at it. So they have what goes in the first blank.
I think it's F.
I think it's F.
Yeah, and I think. Oh, hold up. I'll
Well,
stick
hang
by
on.
it.
Yeah, wait up. Looks like people agree. Yeah, it is F. And this is kind of a giveaway because we all know that tangent is sine over cosine. The only one that actually has sine over cosine is, well, F. That's really the only one that fits based on that piece right here. And it's true. So cosecant, looking at the trig identity sheet, cosecant is equal to 1 over cosine. Okay. 1 over sine, not cosine, 1 over sine. So again, cosecant is 1 over sine, and that's where they got that from. This cosine is from the original problem, so it is F. Oh, I just showed all the answers. Oh no. All right, it's fine. I meant to cover them up earlier. I forgot. So I'll talk about them. All right, next one. going from this step to this step here. We are doing.
He didn't want me to say any more, but he gave us all the answers anyways.
Did I just copy it twice?
Yeah, you did. You failed.
Yeah. Whoops. Didn't mean to do that. Too many blanks. All right. Anyway, I copied it twice. I don't know why. Oops. All right. So going from this step to this step. So I am missing sign. Okay. So going from this step to this step is not as clear. And you would really have to probably look at this word bank. But when you have a fraction, in order to add or subtract them, you have to have the same denominator. Well, this one right here is cosine times sine, but over here is just cosine. So we are missing the sine factor. So what we do is multiply top and bottom of this fraction by sine theta sine theta. Well, sine theta times sine theta is sine squared theta. Cosine theta times sine theta is, well, just that. So that's how you go from this step to this step. And then this piece just carries down. Good so far? I'm going to cross off this. This is just a duplicate. So once your denominators match, which they do, we can now combine them into a single fraction over your common. So cosine sine is your common denominator. We're going to have 1 minus sine squared theta. So from this step to this step, we just made it into a single fraction. Next, looking at your identity sheet, you have cosine squared plus sine squared equals 1. So we're going to use that identity to basically subtract out sine squared. And that's how you get cosine squared is equal to 1 minus sine squared. I don't have it on this page, but it's on your identity sheet. So 1 minus sine squared theta is equal to cosine squared theta. Next, cosine squared theta, cosine theta. Well, one of these canceled out with one of these. And you're left with a single cosine over your sine. So again, cosine squared and cosine, one of these cancels out with this one to get to here. And then from that identity sheet, we know that sine over cosine is tangent and cosine over sine is cotangent. And then that's it. So just work through your identities from your sheet. Good? Super. I'm going to fix my sheet real quick. All right, exact values. So really these, you can just probably type them in your calculator or use your, unit circle. Cosine pi over 3. This one quickly. What do we get? 1/2? Yep. 1/2. I also put these on this sheet because I use them for the second one here. So when you have a negative inside the parentheses of one of your trig functions, in this case it's cosecant. If I go over here to the odd even, cosecant of a negative, I can rewrite this with the negative out in front. So that's what I chose to do. Rather than think of doing like a clockwise rotation, I can just rewrite it like this, and then theta now becomes positive. So I use the odd even identity to rewrite it. All right, next, I'm going to rewrite cosecant as 1 over sine. And then we could just really type this in right now, or you can rewrite it as a coterminal angle that's between 0 and 2 pi. And that's what I did. But it's not the only way. We could actually just type it in as we see it there. So I subtracted 2 pi out of it. That way I get the coterminal angle between 0 and 2 pi. And then this way I could use the unit circle to pull out the y value at pi over 6, which is 1/2, and then negative 1 over 1/2. I'm just showing all the work by hand here. Now you get negative 2. But I'm pretty sure that you'd be able to type this in and get the exact same answer without showing all this extra work. But I would still try it right now if you're wondering. All right, sine of 12 pi. So we could just type this in and hit enter, or again, I can keep subtracting out 2 pi to get the coterminal angle until it is between 0 and 2 pi. And once it's between 0 and 2 pi, I'll be able to use the unit circle. So we get 0. Yep, Antonio, you are correct. All right, let's see what the next one is. Let's start this one tomorrow. Yeah, we'll stop right here. Tomorrow, we'll do this one. I think the problems get a little faster at this point. All right, everyone. Well, thanks for hanging around, and I will see all of you tomorrow.